Zika virus was first isolated from a centennial monkey in Uganda in 1947 until its recent emergence in the Americas. In decades following its discovery, sporadic human infections with mild signs and symptoms were discovered in Africa and Southeast Asia. In 2016, the World Health Organization declared the current Zika epidemic a public health emergency of international concern due to its link to brain abnormalities, especially during pregnancy. Solid evidence from investigations with clinical materials that Zika targets neuronal progenitor cells, which is why it leads to severe pathological outcomes.
The Zika virus is a flavivirus. Zika can be transmitted by mosquito bites from a pregnant woman to her fetus, sexually transmitted, and possibly through blood transfusions. There are two main lineages, African and Asian, though the Asian lineage has been known to be more deadly. In the past, symptoms were non-existent or mild, but now certain strains produce much more pronounced symptoms, which include fever, rash, headache, joint and muscle pain, and red eyes. In pregnant women, Zika can spread to the fetus, attacking neuronal progenitor cells, causing birth defects in the brain, the most common of which is microcephaly. Of the 7 viruses tested to find potential virulence determinants, it turned out that the virus with the most neurovirulence in neonatal mice was S139N mutant virus. It was found that this virus actually caused more cell death, as seen in Figure 1D, with a substantial decrease in phosphorylated histone. When S139N was then tested in regards to embryonic microcephaly, it was found to cause more intense microcephalic phenotypes, so smaller than normal brains, as shown in Figure 1A, along with more infection in NPCs and interruption of NPC proliferation, referred to Figure 1D, which demonstrates how S139N had a bigger effect than WG. In 1B, there is also a visible difference in the thickness of the cortices between the strands. The CAM 2010 strain was first discovered in Cambodia. Vet 2016 is a more contemporary strain of Zika, which emerged from Venezuela in recent years. In regards to microcephaly, the contemporary strands had a larger impact on the cranium than any of the ancestral strands. There was more thinning of the cranium and more apoptosis in the brain. The same trend is seen in other contemporary strands. Looking at this from an evolutionary standpoint, it seems as though the strands which emerged later have some sort of advantage by being more lethal to its victims. There must have been some form of natural selection which caused the more contemporary strands to be more lethal, or at least have a greater effect on the host of the virus, something we learned in Bio 1510.
A single reverse substitution of N139S substantially decreased mortality in mice. S139N showed enhanced replication in HNPCs and caused more extensive cell death compared to the WT virus. Infection of the S139N mutant virus led to more severe microcephalic phenotype and a thinner cortex than the WT virus. A single S139N substitution significantly enhances ZIKV infection in both humans and mice, leading to a more significant microcephaly in fetal mice. A similar virus to ZIKV is DENV, and it was examined due to the commonality of both being flaviviruses. In DENV, the PRM protein was examined, which is essential to viral replication and for the prevention of premature fusion with infected cells. With a mixture of immature, partially mature, and mature particles in infected cells, the first 40 amino acids in the PR domain are involved in interaction in the affected cells, affecting how the virus changes. Thus, the S139N substitution of the protein is believed to directly cause or contribute to change in the severe neuroviolence we see in the contemporary Zika virus today. Basically, with a variation in maturity of infected cells, the virus is more contagious and increases the effects it has on the human brain.
Today you learned where Zika came from, how Zika works, what S139 is and how extreme its effects are, differences between ancestral and contemporary Zika from an evolutionary standpoint, and the different effects between the reversal strand S139 and N139S due to differences in transcription.